All right, exercise 2. Here we go. John Glenn weighed 640 newtons on Earth's surface. We got 2 questions. A, how much would he have weighed if his Mercury spacecraft had hypothetically remained twice the distance from the center of the Earth? So let's focus on A for right now. So there's only one thing, right? They only give us 640 newtons, and we know if it has newtons, it is a force, right? So let's do our formula. First, we straight up write the formula. So our force of gravity equals, what's the force of big G? I always forget the big G. Gravitational constant times the mass of 1 times the other mass over distance squared. What do they give us? Well, they straight up just give us the force, right? So this is going to be like a word kind of one because we don't have all this stuff. So 640 newtons equals gravitational constant times the mass over distance squared. Parentheses, parentheses. So what are they saying? So let's unscramble A because it looks a little weird. How much would he have weighed if he was twice the distance? Okay, so how much would he have weighed if he was twice the distance away? So remember, it's all this over distance squared. So if he was twice the distance, we just kind of put a 2 over here. So twice the distance equals, so let's do it, right? So we're going to take our distance, we're going to square it. So we're going to rewrite this as 640 newtons equals gravitational constant times mass over 4 distance squared. Because we squared the 2. We didn't multiply by 2, we squared the 2, right? 2 squared is 4. So what that means is that 4 is going to go into this. This bottom number is going to go into this less times. So we're dividing this by 4 now. It's going to be 4 times weaker. Right? So if we had our 1 over distance squared to kind of simplify this, and we increase the distance, we double the distance. Well, now our gravity is 4 times weaker. It's 1 over 4, right? So we're doing that 640. We're making it 4 times weaker, which means we are dividing it by 4. So we should get 160 newtons. So it got a lot weaker, right? Now let's look at B. Why is it said that an astronomer is never truly weightless? Well, we know, and there should be a video on Canvas kind of explaining gravity anyways, but we know that everything that has a mass has gravity, and therefore it has a weight of some sort, right? So even if it has a mass of like a gram, it has gravity versus a mass of like something huge like the Earth, right? So for here, however you want to word that, everything with a mass has a gravity, and that's, if it has a gravity, then it's not going to be ever weightless, right? Awesome.